All right, welcome to this explainer. Today, we're zooming in on the exterior anatomy of a computer. Have you ever actually paused to think about those physical bridges that connect our digital machines to the real outside world? It's pretty fascinating. So let's bypass the absolute basics and really dive into how peripherals and ports completely dictate the way we interact with our hardware. Think about it like this. A computer's processor and memory, they're incredibly powerful, but essentially they're trapped. They operate in total isolation. So how does this closed-off digital brain actually talk to us? Well, it needs dedicated physical pathways to receive our commands and, deliver those high-fidelity results back out to us. Okay, here's our quick roadmap for today. We're going to meet your peripheral devices. Look at hardware ports as the gateways. Check out display ports like HDMI and VGA. Move on to data ports like USB and Type-C. And finally, wrap up with connecting networks and audio.
Section 1. Meet your peripheral devices. Let's start with the external tools that give your computer its actual practical purpose.
So, peripheral devices. These are those essential external hardware components that extend what your machine can actually do. We generally categorize them into 4 buckets: input, output, storage, and communication. Basically, they are the real-world interface points for your daily workflow, right? Whether you're typing in commands, rendering some cool media, or just connecting to the web. Take a speaker, for example. It literally acts like a real-world translator. It grabs that internal digital data and pushes it outward into the music or podcasts you actually hear. It's just a perfect classic example of an output peripheral that totally enhances the core system.
Moving on to Section 2. Hardware ports, the gateways. So how exactly do all these external peripherals physically hook up to the motherboard?
Well, that brings us to hardware ports. These are the physical sockets on the outside of your system that link right up to the internal expansion boards. Now, the architecture here dictates the plug design and the types of signals they handle. But here's the absolutely crucial part. They don't just transmit data. They're also simultaneously pushing electrical power to low-draw devices, like literally giving juice to your mouse or your keyboard. Pretty neat, right?
All right, Section 3. Display ports, HDMI and VGA. Let's talk about the visual translators that handle your screens.
The physical evolution of this tech is honestly striking when you see it side by side like this. I mean, we've gone from that older, chunky 15-pin VGA connector to the incredibly sleek, modern HDMI cable. It just perfectly illustrates how our whole approach to connecting displays has been completely streamlined over the years.
So the real game changer here is how they transmit data. VGA relies on older analog technology, literally using separate physical pins for the red, green, and blue color channels, plus sync signals. But HDMI, high-definition multimedia interface, it completely revolutionized the game by showing massive amounts of high-def digital audio and video over just one single cable. No wonder it became the universal standard for all our modern displays and gaming consoles.
Which brings us to Section 4. Data ports, USB and Type-C. Next up are those versatile data and power movers that, let's be honest, you probably plug into every single day.
Good old Universal Serial Bus, or USB. It is your absolute go-to for short-distance digital data transfer. Its sheer versatility is exactly why it became the massive industry standard it is today. I mean, it effortlessly links this gigantic ecosystem of devices, from printers to scanners to your everyday mouse, all through one unified connection type.
And that evolution brings us to the modern Type-C port. Its brilliant, completely reversible shape means, finally, no more fumbling in the dark trying to plug it in the right way. But, beyond just being super convenient ergonomically, it packs serious bandwidth. We're talking ultra-high-speed data transfer and high-wattage fast charging for a massive variety of accessories. It's a total powerhouse.
Okay, Section 5, Connecting Networks and Audio. Let's finish up by exploring the hardware bridges that handle your local internet and your analog sound output. There is nothing quite like that satisfying click when an Ethernet cable locks into its port. When that happens, you are establishing a dedicated, hardwired gateway for local area networking, or LAN. This physical connection uses strict protocols for how data packets are transmitted. Basically, it ensures you get rock-solid, stable, high-speed communication between all your network devices.
Now, even with our massive shift to everything digital, those traditional analog audio ports, the good old audio jacks, they remain absolutely essential. These dedicated little connections give you zero latency transmission of analog audio signals. So, whether you are driving a pair of high-fidelity studio headphones or plugging in a mic for uncompressed audio, these jacks get the job done instantly.
So to bring this all together, take a look at this quick cheat sheet. We can really map out our tech ecosystem based on these highly specialized functions, right? From HDMI handling your high-def streams, to Ethernet ensuring that rock-solid LAN reliability, to Type-C doing all the heavy lifting for your data and charging. Every single physical gateway plays a highly specific, totally vital role in making our daily tech use as seamless and powerful as it is.
As we wrap up this explainer, I want to leave you with a bit of a provocative thought. We've transitioned from those super bulky 15-pin analog connectors to incredibly sleek, reversible ports that can literally handle massive data, power, and high-def video all at the exact same time. So, as our devices just keep shrinking and going more and more wireless, what in the world will the physical hardware gateways of tomorrow actually look like? Will we even have them? Thank you so much for exploring the anatomy of your computer with me today. Keep learning, and I will catch you on the next explainer.